Hi everyone, let me introduce our work, UniGen-1.5, Enhancing Image Generation and Editing through Reward Unification in RL. Let me start with the motivation. Our previous work, UniGen, showed that unified multimodal models can achieve strong text-to-image generation by leveraging their intrinsic understanding capability. However, there are three main limitations. First, UniGen was built on a relatively small 1.5 billion model, which limits its general capability for both understanding and generation. Second, UniGen mainly focuses on text-image generation and does not support more generalized form of visual generation tasks, especially image editing. Third, UniGen improves generation through test-time scaling, such as chain-of-thought verification with best-of-n selection. While effective, this increases inference costs significantly. So in UniGen 1.5, we aim to scale up the model, unlock image editing capability, and further improve generation and editing performance through reinforcement learning instead of expensive test-time scaling. Now, let me introduce the architecture. UniGen 1.5 is built upon a Qwen 2.5 language model. Following the unified multimodal modeling strategy used in UniGen, we use separate visual encoders for understanding and generation. For image understanding, we use SGLIP2 as a continuous visual encoder, and we further use the version that supports processing image with arbitrary aspect ratios and better preserve the native visual information. For image generation, we use a discrete visual tokenizer MAC-V2 and train the model with masked token prediction. The model predicts masked visual tokens conditioned on test token. For image editing, we combine both types of visual representation from the conditioned image. Specifically, we prepend the semantic continuous features and the low-level discrete imbalance of the conditioned image, together with the editing instruction. This gives the model both high-level semantic understanding and low-level visual details, which are both important for faithful editing. Overall training pipeline of UniGen 1.5 consists of 4 stages: pre-training, supervised fine-tuning, added instruction alignment, and reinforcement learning. In pre-training, we train UniGen 1.5 around 40 million recaption image text pairs for image understanding and text-to-image generation. Compared with UniGen, we also improved the generation resolution to 384 and use a stronger understanding encoder. In supervised fine-tuning, we improve both understanding and generation using higher quality data mixtures. More importantly, this is the stage where we unlock image editing capability. We use high-quality synthetic data from GPT-4o image-related datasets, such as shared GPT-4o image and GPT image edit 1.5 million. After this joint SFT stage, the model can already perform image editing, but its instruction comprehension is still not strong enough for challenging edits. This motivates the next stage, added instruction alignment. Before IL, we add a lightweight post-SFT stage called Added Instruction Alignment. The motivation is that during preliminary IL experiments, we find that for difficult editing instructions, the model often generated candidates that all fail to satisfy the instruction. In that case, the reward variance becomes very small for GRPO algorithm. So the IL actually receives weak learning signals. To address this, we explicitly train the model to understand what the final edited image should look like. Given a conditioned image and an added instruction, the model is trained to predict a concise textual description of the desired output image. This stage improves the model's comprehension of editing instructions and makes the IO stage more effective. In the ablation, added instruction alignment not only improves the image edit directly, but also leads to larger gains after unified IO. The key contribution of this work is the unified reinforcement learning strategy. A major challenge in applying IO to image editing is reward design. Editing rewards can be much harder than text-to-image rewards because edits can be very subtle, localized, and context-dependent. For example, removing a small object, changing the style, or replacing one region requires the reward model to understand both the original image and the intended edited result. Instead of building a separate, editing-specific reward model, we reformulate image editing as a general image generation problem. For text-to-image generation, the target description is simply the text prompt. For image editing, we first estimate a textual description of the desired edited image using strong MLMs and LLMs. Then we evaluate the generated or edited image against its text description. In this way, both text-to-image generation and image editing can share the same reward models. We use a reward ensemble including CLIP-H, HPSV2, Unified Reward 7B, and ORM. Then we apply GRPO to optimize the model. Qualitative examples show that after GRPO, UniGen 1.5 improves both text-to-image alignment and fine-grained editing controllability. The ablation also shows that using both text-to-image and image editing during IO gives the best overall performance. Finally, let me summarize the results. On image editing, UniGen 1.5 achieves an overall score of 4.31 on image edit, outperforming recent open source models such as Bagel and UniGen-2, and reaching performance comparable to proprietary systems such as GPT Image 1. On text-to-image generation, UniGen-1.5 achieved 0.89 on GenEval and 86.83 on DBG bench. It significantly improves over UniGen and outperforms several strong unified MLMs, especially on categories such as position and color attribute. For image understanding, UniGen 1.5 also improves over UniGen across multiple benchmarks. Also, our generation-oriented post-training stages do not sacrifice understanding ability. To conclude, UniGen 1.5 makes three main contributions. First, we build a stronger unified MLM that supports image understanding, text-to-image generation, and image editing within one model. Second, we introduce edit instruction alignment to improve the model's ability to understand complex editing instructions. Third, we propose a unified IO framework that jointly optimizes text-to-image generation and image editing with shared reward models. Overall, UniGen 1.5 demonstrates that reward unification is an effective and scalable direction for improving both generation quality and editing controllability in unified MLMs. Thank you for your listening.